Welcome to this explainer. Today we are cracking the code on a massive, foundational topic in Cambridge information technology. Specifically, we're diving deep into syllabus code 9626, topic 4.1, comparison operators. But listen, whether you are tackling 0417, 0478, 2210, 9618, or 9626, the core analytical strategies we are about to unpack apply across the entire Cambridge computer science ecosystem. Think of your exam like the Olympic decathlon. It's not just one event. It is 10 different disciplines, 10 different challenges, and you need to master every single type of question to get the gold. If you are aiming for top marks, you are in exactly the right place. Today, we are transforming you from making the absolute most common, frustrating exam mistakes to achieving total, undeniable mastery over this topic. I am so thrilled to guide you through this material, so let's get right to it.
We are starting with incredibly high stakes today. I want you to take a really close look at the quote on the screen. This is ripped directly from the principal examiner reports. Senior examiners have explicitly identified this as a major trap. They state it is genuinely one of the most misunderstood areas in information technology. Now, why is that? It's not because the underlying math is impossible. It's because students completely misunderstand how to apply and present these operators in an exam context. Imagine two typical students taking this paper. Let's call them Alex and Sam. Alex overloads his answers with raw computer science facts, just pure data dump, no actual analysis, 0 marks. Then you have Sam. Sam is rushing against the clock, completely missing the command word requirements of the question, and just throwing greater than symbols onto the page hoping something sticks. Again, 0 marks. Students constantly drop easy points here because they act like Alex or Sam. We're going to fix that right now and make absolutely sure you aren't falling into this exact same trap.
So here is our roadmap to mastery for today. 1. Core principles. 2. The procedural framework. 3. Critical analysis. And 4. Avoiding exam traps. Let's jump in.
Section 1. Core Principles, the foundation of 4.1.
Okay, here is your foundational toolkit. These are the 6 essential comparison operators you absolutely must know inside and out. We have greater than, less than, equal to, greater than or equal to, less than or equal to, and finally, not equal to. Now, I know what you're thinking. I learned these in primary school math. Let's skip ahead. Stop right there. Do not make that assumption. In Cambridge IT, these aren't just math symbols. They form the theoretical architecture of databases, programming logic, and spreadsheet validation. I highly recommend using a visual story method to encode what each one does. Picture the symbols in your mind and associate them with concrete real-world systems. For example, picture a nightclub bouncer using greater than or equal to 18 to let people in. Picture a warehouse inventory system triggering an alert when stock is less than or equal to 5. Picture a login screen rejecting a password because the input is not equal to the stored database value. Lock these causal relationships in so you can instantly recall their precise definitions during an exam. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, here is a massive secret about top-performing candidates that you need to internalize. The principal examiner reports explicitly highlight that students who actively link these comparison operators to other syllabus areas achieve significantly higher marks. It is not just about knowing what a greater than symbol means in a vacuum. It is about showing connected, conceptual understanding. The examiners want to see that you can take these operators and apply them to completely unfamiliar contexts across the entire IT syllabus. When you see a question about data validation, your brain should immediately spark with, I need to define a range using comparison operators. When you see a query by example database question, you need to seamlessly integrate these symbols into your search criteria. It's this web of cross-topic connections that elevates a basic passing grade into an elite, top-tier score.
Section 2. The procedural framework.
This is where theory meets practice. To capture what examiners call method marks, you must follow this exact sequence on screen. Examiners award these crucial marks for demonstrating your process, not just spitting out a final result. First, deconstruct the question. What is the command word asking you to do? Second, extract the relevant data from the provided texts or tables. Third, select your analytical framework. Many top students structure their answers using something like a PEAL framework: point, evidence, explanation, link. Fourth, execute your analysis using very clear notation with your comparison operators. And finally, present it with the correct terminology. This structured, step-by-step reasoning is exactly what the Cambridge Assessment Framework prioritizes. If you just jump to the final answer, even if it's perfectly correct, you are leaving massive amounts of points on the table.
Let's look at another standardized processing sequence. Notice how incredibly crucial the middle steps are here. You have to execute your analysis with crystal clear working. The examiners are basically detectives. They need to follow the footprints of your logic. Then, and this is exactly where rushing students, like our archetype Sam, completely fall apart, you must verify the results before finalizing your format. Check your work. Ensure that your application of a less than or equal to operator actually makes logical sense with the raw data provided. Does the validation rule you just wrote actually restrict the data correctly? Verify it mentally before you present it in the final appropriate format.
Section 3. Critical Analysis. The academic benchmarks for Cambridge IT 9626 require analytical depth over superficial breadth. When problem-solving using comparison operators, this deconstruct, solve, evaluate method is your ultimate blueprint for success. You identify the given information, you break it down into manageable bites, and you solve it systematically. But I really want to draw your attention specifically to Step 4, checking for reasonableness. This is a massive differentiator between average and elite students. If your operator logic results in a conclusion that makes zero sense in the real-world context of the scenario, like calculating an employee's weekly hours is greater than 200, you have made a fundamental mistake. Always check for reasonableness before making your final justified recommendations. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's talk about the actual writing part of the exam. When analyzing datasets, you must identify both similarities and differences. This is comparative analysis 101. But how do you actually do it effectively on paper? You must use comparative connectives to support your points. Don't just list two separate disconnected facts like Alex would do. Use connective phrasing, words like whereas, conversely, similarly, or in contrast. These words explicitly show how the data points relate to each other through the lens of your comparison operators. This proves to the examiner that you aren't just a copy machine repeating data. You are drawing high-level conclusions about relative significance.
Furthermore, if an exam question asks you to evaluate the quality of a database or a validation system, and trust me, they frequently do, you need to mentally check off these 4 points. First, identify the limitations of the data. Second, note the assumptions being made. For instance, what are we assuming when we blindly use a less than operator on a dataset? Are we assuming all data entered is numeric? Third, find alternative interpretations for this evidence. And finally, assess how these factors actually affect the final conclusions. Pushing your brain through this 4-step evaluation ensures your analytical depth completely obliterates the superficial, surface-level observations that most candidates write down.
Section 4. Avoiding exam traps. Let's reverse engineer the absolute most common mistakes straight from the examiner reports so you never make them. Pay very close attention to these top 3 warnings. Notice anything? Numbers 1 and 2 are entirely about format and presentation. Please, I am begging you, do not lose easy marks on perfectly calculated Boolean logic or perfectly structured database queries just because you neglected to present them properly in the required format. But number 3 is the real killer. It is a classic pitfall. Your answers must be specific to the given context. Examiners completely despise generic answers. If the scenario is about a hospital database, do not give a generic, textbook definition of a greater than symbol. Apply the operator directly to the specific patient records or medical scenarios provided in the exam prompt. Context is king.
Please take a mental screenshot of this examiner alert and burn it into your memory. Candidates consistently confuse key terminology in their extended written responses. The absolute best way to protect yourself, your armor in the exam hall, is to explicitly define your terms before you use them to analyze the data. Don't just jump into the deep end of the analysis. Laying that precise definitional groundwork proves your knowledge up front. It calms you down, it sets the stage, and it frames your subsequent analysis perfectly for the examiner to follow.
To wrap up our explainer today, I want to reiterate this core definition, the method mark strategy. This is the ultimate, undeniable key to passing Cambridge IT 9626 and related computer science papers. Examiners desperately want proof of your systematic processing. They want to see the gears turning in your head mapped out clearly on the exam paper. Show your working, show your logical, structured reasoning step by step. If you do this, the marks will flow to you.
often even if you make a tiny, minor arithmetic error at the very end of the calculation. Process over product, every single time.
I am going to leave you with this final, critical thought to ponder. How will you apply this deconstruct, solve, evaluate method in your very next practice session? Don't just watch this and move on. Remember that consistent, structured practice using these exact frameworks is the only way to lock this knowledge in. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.